Hey, Ford, what's up, brother? Getting the first blood. How are you doing today? Happy Sunday. Okay, give me 1 sec. I am troubleshooting something on the server. That's it. We'll just go ahead and kick it off. I know you can't read this because the terminal is real tiny. I'm not sure what happened. For some reason, unable to SSH into the dev box, which is suboptimal because we need the SSH server to come up so we can port forward a couple of things for our dev server. Check something. Name and password are correct. It's working. I don't get why it's not connecting. Well, if we didn't have weird bugs, we'd have no bugs at all. Double check the settings here real quick. 10.5, 10.10. Our credentials should be good. But we might be able to just get away with doing this as a one-off. It's a little less optimal, but literally do here. Give 1 second. Get this out. This being okay. So minor workaround. Oh, that is incredibly suboptimal. Let me change it over. Try this. There we go. Somewhat legible. A little bit better. All right. For some reason, I don't know why, but Royal is just absolutely refusing to make its proper SSH connection. But I think everything will still be working. Okay, hold on. I think I finally actually just saw the problem. Hold on, was that it? So this is weird. Instead of embedding it, it's just opening it up in a new window. What the crap? What changed? This must have been a change. I just realized something. So this tool that I'm using, this is called Royal TS, and it is great for managing multiple connections. So I got just all my standard connections set up here. One of the best things it does is it actually helps with doing port forwarding and tunneling over SSH servers. That's why I like using it so much. The downside, however, is they just pushed an update, and I believe that is what's broken it. And I updated it last night after the stream was over. So let me see if I can find what they might have changed in here. Window mode. Okay, maybe I just had to reset that. Let's go try. Ah, I didn't mean to close that. Crap. It just opened another putty window, which, I mean, I guess is technically fine. It's just kind of annoying. I mean, it'll still work. It's just rude. Alright. Well, whatever. Fun times. Always new fun times in IT land. What's up, everyone? I hope everybody's having a fantastic Sunday. Had a crazy, not really a crazy day today. It was a pretty relaxed day. But then I let my kids watch the Minecraft movie, and they just absolutely lost their minds. I swear, you might as well have just thought you gave them baby crack. They just went straight past 10 and 11, just straight to like 12. They got dialed up to 12. It was insane. So I told them it's gonna be a long time before I let you watch that again, because y'all both just lost your ever-loving minds. My older son, Agent Zero, he so excited over the movie. He was running around the house because he couldn't sit still because he was just so excited about it. Oh. I just realized something. I forgot to boot up the Hack the Box room. So kick that on. There we go. Awesome. So we'll go ahead and bootstrap everything up for tonight, and then we'll work on the exploitation agent. There we go. It is kicking on right now. So we'll give this a couple seconds. Let's actually make sure that we're communicating with the LangGraph server properly. All right, so some of our port forwards are not actually functioning this way. Well, here I thought everything was working well. What is going on here? My computer's acting all kinds of funky tonight. Yep, so for some reason, the update has busted the putty integration, and it has busted the port forward. That is less than helpful. See if we can adjust this setting. Let's see, plastic reparenting method. Client area, deeper integration with correct alt tab. Okay, let's try this. Maybe we can get this to reconnect. For some reason now, when putty's connecting, well, at least now it looks like the port is actually formatting properly, or forwarding properly. Let's go check it out. There we go. Cool. So we're able to connect to the studio. What's going on here? All the technical issues tonight. That's fine. Close that up. And then let's go grab our IP address and let's bootstrap everything. And add an hour to it. All right, let's get our seed data going here. Wait, is that actually the correct address? 10.10.247.0? Oh, guess so. All right. Always funny to see an IP address that ends in a 0, but it is technically correct. Go over to Stinger, drop this in, and let it run. The only reason why we're having to rerun this actually is because the target IP address changes all the time. If the target IP address stay, but you can't see because my big head's in the way. This IP address stayed the same the whole time, we wouldn't need to rerun this. So if we were self-hosting the machine we're testing against, it'd be no problem. But let's go rebootstrap it. This will save our pickle to disk, and then we should be good. Actually, what's crazy is now it's actually going to start running through some of the exploitation tasks. So probably I need to see an interrupt on. Actually, come to think of it, I don't know if I can set an interrupt on the internal. I know it's hard to see right here, but like, ooh, so when it's running subgraphs, we cannot interrupt on individual nodes. Well, less than ideal, but you know what? It'll still work. Go ahead and open the trace up for this one. I'm excited because I wanted to start getting a little bit more of the logic and understanding coded in for the exploitation agent, because we were starting to kind of get it to come back and forth. But again, this is like working with a hyper intelligent 4-year-old. So we've got to massage how we're talking to it and what kind of information it's giving us back. One thing I've noticed is Claude tends to be very chatty. It always wants to give a lot of like exposition back about whenever it's doing something. Let's see. So it's currently running through the enum task. What's our current task we're on? All right, so it's doing an HTTP GET. Patching that data over into the host object. Sweet. So once it finishes with the enumeration tasks, it'll pass over to the exploitation agent, and then it'll run the pickle. But then also, the good thing about this is, here in the trace, we'll actually see what was going on with the exploit agent. So we'll have a good testing starting point too. Because as soon as it hits this in here, it's going to pickle the state table, and then we can just rerun the exploitation agent and call it good. So that way we don't have to rerun the entire workflow. I know there's probably a built-in method to do this with LangGraph, like saving a state and then maybe pulling it back in with various threads. I just don't know how to do it. So I just kind of rolled my own solution for it. Let's see where we're at here. Oh, cool. Looks like it finished the run. Awesome. So let's go double check that pickle file real fast here. Our data pickle updated June 8th. Perfect. Great. Sweet. So that one is nice and updated. And then to do one other thing, we'll have to copy that over to agents for when we run just the exploitation agent. All right, let's look at the trace here. Cool. So when we passed over to the exploitation agent, we hit the exploit agent. It took in all of our input. Collapse this down. Here's our message history. Can I collapse that? Yes, sweet. Well, let's see. Okay, so exploitation agent said, hey, we're starting a task 5, get the remote code execution on the web shell. And then over here, we said we're going to send it to the validator for the pre-flight check. Now, where did we route to? Exploit router did route it over to the validator, so that's good. And then where's our actual language call here? So the task was get a remote code execution from the web shell. For some reason, target was blank. Okay, we'll have to go investigate that because this field should not be blank. So there's one bug we need to go dig into. But we gave it all the information about the host that we had. This is what this context is. Basically, it's a JSON stringified version of the host dictionary that we've got over there. Let's see, based on the information provided, I can see the target has an Apache web server with the file upload functionality at /panel and an uploads directory where files will likely be stored after upload. Perfect opportunity to attempt to upload a web shell for remote code execution. So then it actually comes back and starts returning our exploit task. Very cool. Sweet. So let's start digging through this part just a wee bit. Because what's going to happen here is it's returning a bunch of stuff that is extraneous. Like for some reason it's giving it like a task ID. It's giving it all sorts of other information here. And let's go look at where that's actually supposed to return back. Pop back over to the exploitation agent. So right here, what it's returning is this exploit task, whatever we bind it. So what we're doing is we're not actually making a tool call. Instead of using the structured output version, what we're doing is we're faking it by sending it basically a tool call with only one tool. And so then it invokes it. It's a very dirty way to get it to take its output and make it structured as JSON and then give it back to us. So this exploit task right here has a couple of different fields into it. Maybe this is overcomplicated, and what we probably need is something a little bit less crazy. Let's think about this. Let's walk through the workflow again, because we've had a lot of different opportunities to overlook this, because we kept having to bounce to different parts of the code, because as it was executing, we were finding various functions and errors, and we were addressing those, and it kept interrupting work on the exploitation agent. So let's start with the basics. Let's go look at the prompt template here. So this is our exploit suggestion prompt, and what we're telling it is, you're an expert cybersecurity agent. Come on, drag this over. Your primary job is to analyze the task and the target to speculate on exploits that could be viable. So additional context may be provided for previous failed exploit attempts that could be modified or avoided. Responses should be in this form. And then we had one bug here where for some reason target was blank. So where was target actually? See, this is weird right here. So the target, we initialize target up here, right? We just give it, hey, this is a, right here. So there's our target. But down in our code, once it actually reaches the point where we're going to make the language call, what we're doing is we're appending that host object to that list, basically making it very simple. I wonder if we shouldn't adjust that. Rather than making this here, where was it? So the definition is that we set a list of hosts for some reason. Why did I make that a list of hosts? Was there something I was thinking about with this? I don't think so. We just want to make that a one host. Yeah, I know that's what you're expecting. Expecting a host object there. But that's fine, because we're gonna actually go through and set it down here, but need to adjust this. This is no longer going to be an append. This is going to be an equals. So we're extracting that target data, and then now it should hopefully fill in. Because what we're seeing is over here, what was it, during the validation? When the validator ran, for some reason... Oh, that's not it. Where is it? Oh, it's in here. That's where it was. So whenever it ran with our prompt, for some reason the target didn't actually come through. So let's check real quick. So this is if it's assigned to exploit and it's set to working, which it should be. Let's go check that actually real fast. Because we can check the... Right here on the input, we can actually check the state of the task here. So current task is 5. We look at index 5, the task. It was set to working. So whenever we hit this this exploitation agent node, the input showed, hey, we're in a working state. So if it's in a working state, something up. Oh, I accidentally tapped that over. Oh, maybe this is where the error is. So if it's in working, let's see. It says the task is in a working state. Did we see a reworking message? If we did, we know what the execution flow was. The easy way is let's collapse this down. So we just need to be able to see the end of the message here. Yeah, so then we got no initial access payload available, passing to exploitation agent. And then it says it's a reworking task 5 right here. So, okay, that's a little bit of a misnomer because it's not actually working it. Or it's not reworking it, it's actually just working it for the first time. Weird. Let's look back to the message log. Did the same thing happen with, like, recon? Because, for a little bit of context, what should happen here? Let's look at the recon agent as an example. Move this right here. Move handoff down here. There we go. Let's kind of rearrange this a little bit. So what happens here is when a task first comes into the agent, the recon agent is going to check the status for it. It's going to look to see, do I have a currently working task? If it doesn't, or if it's basically, if it's set as new, it immediately actually sends it down to the validator saying, hey, here's our target. Can we answer the question or complete the task with the data that we've got? If it doesn't, it passes it back up to recon and then lets recon start working on it. And it does this by looking at the pre-flight check for the host object. So, or sorry, not for the host object, for the task object. So it looks in the task, says, has the pre-flight check been completed? And if not, then boom, we send it down to the recon validator. So let's go check the recon agent. I want to see what the workflow is. Does it say it's reworking it when it's actually not? If it's not a big deal. It's just a semantic error, more or less. But I'm curious now. So we said starting new task 0, which is scan the target. We got an AI message back. We got a tool call. Actually, I don't see it doing the check and the rework here. So for the first task, it didn't. Let's see. We passed it to enum. Enum says I'm starting a new task, which is number 1. sending it to validator for pre-flight check. So that's a little bit odd. I need to go maybe double check that in recon, because recon did not perform a pre-flight check on this. So task 0, there was no pre-flight check taken care of. We did validate the task, make sure everything was running correctly. What service is running on port 22? So we send that for a pre-flight check. Well, let's see. And this one actually gets answered, so that's no problem. Really, the one where we need to use GoBuster should be the one where we see that. So, because the other ones, like what's running on 22, what's running on 80, those should be answered from the previous nmap scan. But if we go to GoBuster, it says, let's see. So we're sending it to the validator for pre-flight check. Good. Task unanswered, passing to enum agent. Okay, so it does say it's reworking it, which is fine. That's not that's just a very minor issue. I'd rather it be like, hey, we don't have any output. We're starting with it. I don't really feel like messing with that logic. So it's reworking it. Okay, so that's not the kind of bug that I thought it was. Perfect, though. One less thing to deal with. All right, let me check something. So Stinger State, we do have a list of tasks. For our host, what we have is actually, correction, this should have been in our task list. Got sidetracked for so long. I'm trying to remember exactly how I structured this. So I think I'll do it is we'll just diagram this sucker out. Let's see here. So if I remember correctly, the idea was I'm trying to remember where we were storing the exploitation task. I want to say it was with the task in. This was something that was going to be unique to the exploit agent. Typically, this state table is 100% shared, identical between all the various agents in here. So, we look at the graph here. Let's collapse these down real quick. So each of these is an agent, right? We have recon, we have enum, we have exploit. Each of these is their own agent, and this overarching one is the supervisor, right? So each of these agents shares the exact same state key. You could actually make it to where these guys had their own, like, different type of state table, and as long as there were shared keys among that type's dictionary, you'd be fine passing data in and out. As I thought about it, I was like, there's not really any point. There's no efficiency to be gained by making it that chopped down. So instead, they're just passing around the same style of book, which is called the Stinger State. But where did I put this? Go read the code again. So I'm trying to remember here. So we appended that as a tool, which this is, I have to change all this. This is not. I think we might have to expand the task here a bit, maybe. Because we need to be able to work with exploitation tasks, but the problem is the exploit tasks, these ones right here, we don't have a good place to store them in the state table. So let's think about where we might be able to put these. Yeah, because here was I think this was the overarching flow. I wish I had diagrammed this out. If I did, I probably lost it. But, so. Kind of the idea here was that, right, in the stinger state. So we have a field in here for our tasks. And then somewhere in here, what we need to do is we need to store this as an exploit task. And then again, nested under the exploit task, we're going to have something called a mini task. And the mini task should have been like individual steps. So the idea here was for the task was, let's say, like exploit host X. Actually, let's change that. Exploit host Bob, just to have a solid name here. Exploit task might have been something like drop a web shell. But then mini task would have been things like, okay, we need to find like a file upload. I cannot even write. Let's see. It would have been something like, hey, find a file upload. Let's see. Upload and then like test execution. Jeez, I really can't write tonight. Let's see. Test execution. So each of these would have been like their own individual mini task. And each of these would have been stored in here under this exploitation task. So I think this was something that we hadn't addressed yet was, where do we want this exploit task to hang out in here? The exploit task and the regular task are very similar, right? And in fact, the exploit task has a task ID field that should link it to this task right here. I'm thinking either we extend the task object here, so either we extend the task object or we assign it to the host object. Where would be the best place to kind of stick this in here? Think about this. Really, my gut tells me associate it to the task because it makes the most logical sense, right? You have a task and then you have an exploit task associated to that. These exploit tasks, there could be numerous, right? Let's say we prompt the language model and says, oh, just judging by the data that we've got in here, there's 3 potential paths. Maybe one of them is upload and execute a web shell. The second one is maybe we brute force telnet. Maybe the third one is we find a local file inclusion and we steal Etsy shadow. Maybe just for an example. So each of those would have been their own exploit task as we're going through this. Hey, Cypher, what's up, man? Hey, Dr. Lou, how are you doing? Happy Sunday, y'all. Happy Sunday. All right. So we want to take this list of exploit tasks, but how do I want to map this over to the task in here? Other option is we come over to Stinger and we expand it out here. Since we do have a field here, and this is completely up for changing and probably will change completely, this exploit task and what we're going to do. What if an exploit sub mini task got stuck? Do you have any more robust plans? So let's say, are you talking about like if it exhausted all the ideas for the mini task to complete an exploit task, or if it runs out of exploit tasks to do? Is that what you're asking? Because what I'm thinking here is The idea is while we're working a task, there's going to be, if we look at the graph here, let's pull up the exploit agent. So if we look at the exploit agent here, this is what we've got right now. It's very similar to the other agents, but that's because we haven't finished adding any nodes in, which is fine. Once these various tasks start happening, what'll happen is there's going to be another branch off to the side that's actually going to be executing the exploitation task. So there will be additional logic we're going to throw into the exploit agent that says, okay, by the way, do we have an associated exploit task to this task? If we do, let's start working that. And there will be a second branch workflow that happens over here where it starts executing the mini tasks associated to. In fact, I'll probably change that name because I'm getting task overload here. We're getting verbiage overload. Maybe I'll change that to like an exploit step or something instead of a mini task. We'll rename it for clarification. But what'll happen is there will be a second workflow, largely based off of something like the Reflexion agent, where it goes through and attempts to complete each of those tasks. If it works, then what would happen is, or let's say it runs into an error with that. So for example, in this test, you cannot upload .php files. You have to have a workaround to that. In this case, it's uploading it with the extension .php5 to get it to execute. So it should run into an issue where if it runs into an issue, then we'll say, by the way, here's the error output that we got. This was the response from the upload. It did not complete. How do we do this? And then it would go through and make revisions and attempt to do this. If it couldn't be able to finish the task to assign to it for, how do you quality assurance your agent by an automation way? So eventually, I fully expect the agent to get stuck and not be able to complete its job. In that case, in the future, there will be basically a fallback to human input, where a Stinger would come back and say, by the way, we're unable to complete this task. Here was the task, here was the stuff completed. What do? And then the human would come in and say, try this. So I fully expect that to happen in the future, just not there where we need that yet. Did you just tell it to try harder? I forgot who it was. Was it you, Cypher, that's like, try softer? That one cracked me up. Did I write that one down? Hang on. Yeah, try softer. That one, I forgot who told me that one, but if I ever decide to make merch, I'm going to put that one on there. Especially with all the PTSD I've had over the years of try harder. I still get a little twitch in my eye from it. Let's say you want to build LLM way automation and no human intervention. How do you solve the problem then? I mean, that's going to be one of the other ideas, Dr. Louvre, is we would have eventually we're going to put in a web search tool where if it runs out of ideas, then it can come through and it can go perform a search for it. I'm kind of holding off on that for two reasons. One, all the systems we'll be testing against are going to be, let's call them like public source, retired systems, things where people have put write-ups online for them. The thing I don't want is I do not want the AI agent to come across the write-up. And I don't want it to then just follow it step by step. Now, while that would be the ideal way to do it, as we're sitting here talking about it, there are times when I have been trying to exploit a system, even on a live pen test, and I actually have come across a very similar method in a write-up for something like Hack the Box or Try Hack Me. So I don't know if that is the best approach, but that was my initial thought. Was I wanted it to be able to search for things, but also have guardrails around it where it was not finding the write-up for the CTF and then just blindly following it. I think that would be probably one of the fallback methods there, is if it runs into a roadblock, then it will begin performing web searches to gain additional information. All right, let's see here. So let's do a little bit of refactoring real quick because Minitask is driving me a little bananas. So we have an exploit task. Let's do. I'm gonna refactor this. I think it's. Yeah. We're gonna call this an exploit step. There we go. So the exploit step is going to be those individual ones in our list here. So this is no longer a mini task. We're going to call this an exploit step. So because there should be a task, like, okay, the task is get a web shell to get remote code execution on the system. The steps would be upload it. And for this particular system, it would be, hey, go ahead and upload the web shell, get an error because .php is not allowed, find a workaround to it, upload the workaround version, possibly repeat that a couple of times, and then ultimately do a command execution to see did it actually exploit it. All right, let's see here. So we have our exploit steps. In fact, I'm going to rename this to, I'm going to call that steps rather than subtasks. We'll call those our steps. Still got to think about where I'm going to attach this to. Like I said, my thought was attach it over to really another possibility is we attach the exploit task over to the host. We keep it there. But we have so many operations where we take the entire host object and send that to the language model. And we're trying to keep the language model from having blind spots, very tightly control how much data we send to the language model. We want only the minimum high quality data that we send to it. Because if we start just throwing the freaking Library of Congress at it, it's going to get blind and it's going to be missing things. There are ways to compensate for that, which is the data gets reorganized. And so you can try to avoid the blind spots, but then you have to have a consensus. You're burning extra language model calls. Really just working on making the data you're sending to the model the most efficient seems to be the best path forward. Sometimes the simplest thought hits the deepest. Yeah, like the try softer. That one cracks me up so much. All right. All right, so let's examine this idea. So if we're going to take the exploit task and associate them to the parent task, I guess we would actually, this would be fine. We could drop this task ID. It wouldn't be an issue because it would be directly collected to it. One thing also we'll probably do, because you look at the data we got back from this exploit task. Right, when it did this language call or this tool call here, we got so much extraneous data back. Really, only thing we need, we don't need this. We don't need this. We don't need this. We don't need the tools. What we need is literally just a list of the ideas and then the subtask for those ideas. So we can go rework our prompts to get that cleared up. But also what we can do is we can make an output formatter to clear up this data here. And the output formatter would say, basically just give us back the fields that we can only get back from the language model, and then we mesh it in with the hard known data we've already got. LLM overload mode. LLM overload mode.
You sound off like you got a pair.
Oh, eat my shorts, Gumby. Let it recall, remix, and exploit functions from the doc on demand at that point. Yeah. And that's pretty much what I'm thinking. I do want the search tool to be in there. But you gotta think, a lot of the stuff that these language models get trained on is stuff that's scraped from all over the internet, legally and illegally. Let's be 100% honest about that. So part of that will be it's already going to have some knowledge around cybersecurity and exploitation, literally just baked into the the neurons of the language model. So we can use that to our effect, use that to our benefit, but then there will be times when we need to have more specific data that we can feed into it. Gumby, the weather is looking like rage. Let's see. Last I checked, we were under a severe thunderstorm watch. Now, for those of you who don't live in diabolical weather locations, a watch means you have all the ingredients for something. A warning means ingredients are mixed and happening. So let me give you an example here. This is a cake watch. This is a cake warning. That's how you tell the difference in the weather. If you're not sure the difference between a watch and a warning. Cake watch, you have all the ingredients for the cake. Cake warning, you have cake. Here's another good one. The cake watch versus the warning. That's how I remember it. All right, let's do some stuff. Let's take this. I think the task ID is going to go bye-bye. We're not going to worry about that. What we'll do here in our task is actually, I think really now this is a list of strings, so we could not throw the exploit task in there. I'm trying to think if there is an elegant way to put this exploit task into the task list, or do we just need to expand the structure and add a new field to it? That's what I'm trying to think about. I've grown so numb to to watches. Oh, dude, fast. Me too, man. Especially I've lived in Texas. Let's see. I'm 41. I lived out of state for 3 years. Let me think. Is that right? Maybe it was 2 years. For a couple years. And actually, I was not born in Texas. My parents moved here when I was a year old. So, but for the most part, for 38 of 41 years, I have been in Texas. Severe weather and drastic weather that changes on a dime is nothing new to me. Severe thunderstorm watch for the Dallas area until 4 a.m. Yeah. Yep. Thankfully, I have a weather alarm that if the really, it hits the fan, it will just make a very loud, obnoxious sound that wakes me up. So if it really gets down and dirty, it's funny because I know some of my friends that have moved here from out of state and they get freaked out by the weather, especially around Austin. So let's be real, most of the California transplants to Texas moved to Austin. That's you think of Silicon Valley being in California. Austin is kind of like Silicon Hill, is what they call it. But they're obsessed with the weather, just absolutely, because they're just not used to it. They're not accustomed to it. They haven't developed the pattern recognition to know what is threat, what is not. So I'm so completely numb to it, like you said, Fast, that yeah, I have a special alarm that just goes buck wild and will wake me up if something bad's happening. So hey, by the way, a tornado was actually spotted on the ground. Oh, okay, yeah, let's wake up and go get the kids into the closet. The sky's not green, no need to worry. Right. Speaking of green, back to rocking the green Jockos, which you can't even see. Which is funny because it looks like I disappear completely behind it. But they're tasty. What is this? Lemon lime flavor. I actually they have a sour apple one. Or used to. I need to see if I can get it. It was called Sour Apple Sniper, and then they took the sniper part off. I was like, why? That was awesome. Love that. Oh, PDS is particularly dangerous situation. Oh, okay. Did they actually upgrade it for this area, Gumby? Hang on. Let me see what the National Weather Service alert said. Let's go see. Severe thunderstorm watch until 4 a.m. on Monday. Includes 34 counties. Yeah. I don't see them saying it's exceptionally severe, though. I mean, when I was looking at the map earlier, it said this was covering a fairly large area of North Texas, and kind of like the butt end of it was the Dallas-Fort Worth Metroplex, and then it shot up into Oklahoma, kind of to the northwest. 80 to 100 mile per hour winds are possible. Oof. Let's see. Palmer said, I can verify I live about 20 minutes from Austin, and we've had a lot of bad weather recently. Yeah. Yep. That is just good old Texas weather. Oh, that just came out. Okay. Well, thank you for the heads up, Gumby, my own personal weatherman. Appreciate you. Hold on. How is it that all the kids do it this? Like, no, it's like this. There you go. I felt so old trying to do that. In my fingers. I felt old. Oh, damn. Let's see. You know, one thing we could do, we could, in theory, expand the tool here. Actually, I take it back. Look at this. Thanks, Past Me. I actually already had this set up. We had exploit tasks already set up for this. See that? The output was a dictionary or an exploit task. So we have an exploit task. So what we do is we append this to the output of the task here. In a really weird way that does make sense. And Past Me is a tiny bit of an evil genius, because by putting the exploit task over into the output, a lot of the validator logic already works. Some of the validator logic was to take that output and basically check, did it actually do what we were supposed to do? I'm a trained storm chaser and hacker on the side. Dude, I wanted to be a storm chaser so bad when I was a kid. I thought that would be really awesome. And instead, I decided to become a hacker. Okay, so since Past Me already had an idea for this, let's go take a look at this real fast. Let's redo our drawing a tad here. So let's take this, bring this down just a wee bit, and then let's go over here. So for tasks over in output, then in output we had the exploit task listed in. So this was our output array. Ought to hit you up whenever I chase in Texas again. Yes, dude, let me know. Chances are probably 99% I won't be able to go with you, but in that 1% chance, definitely let me know. Awesome. That would be sick. Oh, let's see. Okay, actually, I think that wouldn't be too bad here. So we'll take that exploit task. Our exploit task is going to go over to our output. Exploit task is then going to have exploit steps associated to it. Actually, this works out so well, because let's say, for example, we had 3 exploit tasks that we were trying to figure out which one works, right? Then we go through the exploit task, we find out it fails. Bam. We go to the next, we start a new exploit task. It gets appended to the output. We can see all the steps that it took to attempt to exploit the host. Oh, ooh, Daddy likes. Thank you, pass me. See, there's our target IP. Oh, that's probably why, because we expanded this a little bit. So we still need this target data here. This is if we're adding a blank entry to the state table. I think the problem actually is just a matter of scoping this right here. So what we're doing is current task output gets appended onto this. Let's go look at the language call real fast here. So in this case, our context was the actual host object. So we had, so it comes up here. We got to make sure all this stuff kind of meshes. So what I'm trying to do also, if we look right here, each of these nodes basically will only have one language model call that it makes. It makes it a little bit simpler for tracking how we're passing this stuff around. So if we have different prompts that we're dealing with, we don't have to worry about like what's the input and output. We can have basically one language model call per prompt as it goes through here. And you can see this actually over in Recon. I didn't even realize I was doing this until I just thought about it. But like, for example, tool node, that is one language model call. Or not really, but agent only does one language model call. Output formatter only does one call. Host update only does one call. Validator only does one call. So each of these, basically one call per node kind of structure, helps keep it clean so we can track where things are going. Make sure we've got the appropriate prompts, and if we edit a prompt, it's not going to break some other associated call that just happens to be going on with that one. All right, so let's go through and make sure that, because I believe after we modified this prompt right here, all this prompting information, this is where things kind of got wacky. I think rather than setting this information up here, we might just want to come and set it down here. So maybe take these pieces out and then migrate them down to set up the prompt. I think that might make it a little bit simpler. Let's see, target IP we do want to extract from the task. Well, actually, we already have the current task in here. Let's see, so this is, the task is working. We're saying we're going to rework it. That's fine. And actually, I think we could just modify it right here. We just come in and add that single piece of information in. Where did I find target IP? Did I just find that up here? No, I sure didn't. Okay. If I remember correctly, the way Python handles these, like this is a new variable and we're using it just in this scope right here, then basically once this if block exits, that target IP variable goes away. Same thing with this one. This is in this elif block. let's think about this. Yeah, I think really we just need to modify it up here because the field that was blank is, where is it? The target right here. And then let's verify that real quick. If we look at our prompts, how do we describe that it should handle the target data? We're telling it the task in target to speculate on exploits that could be viable. Okay, yeah, so we actually definitely need to rework this because the target data should be the host object. The context would be any previous output from this task, which in this case would be exploit tasks as they come through. Yep, so let's go ahead and rework this just a wee little bit. Let's rework this. So our context is not going to be the target IP here. Let's make sure I'm not going to bust anything up when I do this. Okay, so we do want to take out the task string. And in fact, I can even just clean this up. I don't think I'm worried about this part right here. I'm going to comment this out. In fact, I'm going to take this out right here. I'm going to drop it directly into this line, just like that. So I'm going to take that out. Let's clean this up a bit. All these kind of various task strings and variables, I'm going to just kind of swap them. Yeah, actually, I take that back. I do want to kind of leave that as it was. Those I do want to kind of leave in just because it makes it simple that if I need to go modify that, it's just one spot to go. That's it. So let's look at this real quick. So this has our, we check to see the task is assigned to exploit, if it's working. If the task is validated or new, we've got our logic handling it here. Okay. What else do we have target IP used here? I don't believe we do. As we come through here, let's check the rest of these. Target host, this makes sense though, because this is going to be our get stub here. Although this doesn't really make a lot of sense to have this extracted out into a single variable. So let's just go ahead and make that one line. And we'll clean this up a bit. Or did I do this wrong? Wait, what just broke there? Oh, let me back this out. What happened? Oh, yeah, I see what's happening here. Yeah, we had to, okay. Yeah, I see what's happening. This is why we did this. So what we're doing is we're getting a stub host. So basically saying, hey, we have a task assigned to a new host. It doesn't have anything associated to it in the target table. So what we did is we generate a stub, basically a new entry to go put into the host table, and then throw it in here. Okay, I guess that'll be fine. copy this. How to access this. That should work. So this is what we're setting the target. However, actually, I think I really don't want to worry about this. This is setting our target and our context. Where's the target actually used? Looks like it's actually used down here. What I'm going to do is comment this out. And the same thing here, because the context should be, all these should be like fairly handleable fields, let's call it. So for example, let's do task string. This is going to be our state table. And then what we're going to do from there, we're going to get our tasks. And then from there, we're going to use the index of state. And then our current task. That's our index value. And then we want to extract from that the actual task key. There we go. That's going to be our task string. Our target is, again, reference that from our state table. We're going to go to hosts. And then out of hosts, we want to get the state table. Again, our current task. That should be completely set. That should be no problem referencing that. And then from our current task, we want to get oh wait, I take that back. This is a little bit different. Let's go look at our state table. So here's our task right here, and then our host table right here. It's keyed on the IP address, so we need to take out the IP address and use that. So actually, that works fine because our current task. So this one's gonna get a little bit crazy right here when we do this. I think actually we'll bust this up a little bit because this is gonna be one very long, weird, referential look at things. Because what we're gonna have to do is we want to pull out the host object, which means we need to get the target IP address from it, indexing off of the current task. So what we're gonna do is we're going to get the state table, and what we're going to reference off of this is, what is this? This would be host, and the host we want to get is the current task. No, wait, I'm getting this all screwed up. Hang on, let's back this up. So for the host table, what we need is we need the target IP from the current task. So what we want is we want the target IP, but to get that, we need the current task. To get the current task, what we're going to do is we're going to get the state table, and we're going to get the tasks, and then off of the index that we want from the task, it's going to be from the state table. It's going to be the current task. Oh, this looks fugly. Let's see. Current task. All right, so look at the execution of this. We get the current task index value. That indexes us to the correct task. That task then gets us the target IP, and then it comes to the host table. Okay, perfect. Ugly. But it works. It should work. And then the last thing we need is the context here. So our context is going to be the state table. We're going to reference our task list. And then out of the task list, what we're going to get is, again, the state table current task. You know what? I really do feel like that current task should be kind of busted out a bit. Yeah, as much as I'm trying to avoid this just a wee bit, but I am going to do that. What we're going to do, make this task ID. This is going to be our current task. And then now anywhere where we're referencing the current task value, we just reference it here. So we'll go to our task ID, and then from there, what we want is the output, because that is going to be the output of all of our exploit tasks. So in this case, context should be blank. Target should be filled in. So this was a little bit backwards in our language call here, right? Target was blank, but context was, it was still working, but it wasn't actually what we wanted it to do. So let's make a little note here. These are our prompt variables. We'll call these our helper variables. There we go. Let's see. Yep, so that should work. Task string, target, context. That should fix that issue there. And then I think the next thing we want to do is we want to modify the prompt just a wee bit. Actually, this is the part we want to modify, this exploit task. Because we don't want it to... And what we'll do is probably come over to... Close the tester. Over here in our utilities, we have tasking. Over here in tasking, what we'll probably do is we will add a... We'll basically do like this, like get new exploit task. We'll return something like this right here. Or no, not like this. This is different. This was hunting for a new task in the array. So we're not worried about that. What we'll look for is we'll take something like the bare minimum pieces of information that we need. So we'll set up an output formatter, and then from the output formatter, we'll take that and, well, actually, this would be the one we would do. This one says expand task basic info. So when this node here in Stinger, whenever it gets a task and it expands it, if we look at the calls to initializer right up here at the top, notice we give it an object called task basic info. And if we look through all the various fields, it only has a couple of the fields for the task. The rest of it, we already can interpolate and figure out. So we're just asking for the bare minimum amount of information that we need the language model to process for us. And then here, what we're doing is we're just expanding it out. So let's start with the output formatter side. That's the one thing we're going to need. So we're asking it to return us So what we're doing is we're asking it to return us an exploit task here. The exploit task, we don't need the status. We don't need a verdict. We do need steps. We do not need the target IP or the tools or the output. Really, we don't need any of this stuff. Really, all we need is the steps. So these are our exploit steps here. In fact, I'm even going to rename this to, just for clarity, I'm going to call this a step task. There we go. We can leave the status for now. We can leave the tool. I don't know if for the exploit task we actually even need the tool. Really, the steps should do it. Let's see. So if we busted this out, we do want the output here. Even though this really shouldn't be a list, I'm leaving it as a list for now, in case we need to go expand stuff out of it. And I don't know if we actually need an answer. What we might do is actually just have it render a verdict, like successful, non-successful, or success or failure in here. I think that might be well. Let's do that. Let's make this a literal. And then take this out. No, not there. Take all this out. What we'll do is we'll say success or fail. really that's the, and actually it doesn't even need to be an answer. This could just be our verdict here. So we want to know, do each of the steps succeed, right? If all the steps succeed and we're able to get the exploit to function following this series of steps, we're Gucci. Ooh, looks like the weather is going to be coming in maybe about the end of the stream time. Yep. Here, check this out. I was just checking the weather to see how things are coming through, and so there's Dallas right there. So good news is, it looks like about the time we're finishing the stream is when it's going to hit Dallas. A little bit before. We might hear some thunder in the background. I'm trying to click it here, but this is on the iPad. Try to pause it. Oh, funny. All right, let's think about this. So we don't want a step task. We want, what is the status of it? Do we even need a status? I don't even care about validate. Actually, we do want to validate it because we will pass these steps over to test for validation. Let's see, we do want what tool we used, we do want what output we used for these steps. I think that will work. Target IP tool output. Okay. I don't even know if we need tools and output for this. I'm actually going to comment these out. I don't know for the exploit task if we actually need those. Really, only thing we need for the exploit task is the steps. So this is what we want. So, and literally all we need is this right here, which is one of the task steps. So let's come over to output formatters. Let's go make a new output formatter here. Let's see. Put a note in here. These are tools specific output form for special cases. There we go. Keep those a little bit separate here. Let's do something. Let's do a class, and we'll call this exploit steps. That will extend our Pydantic base model. And then what we want here is our steps. That's just going to be a list of strings. That I can't type. There we go. And what we'll do is we'll define that as Pydantic field with a description. Bring this over a bit. The description, this would be a list of steps. A list of steps to execute in order. Let's see. To complete exploitation, or yeah, to complete an exploit task. Actually, we'll just say to exploit a target. Looks like it'll be in McKinney about 10:18. Man, that's kind of wild too to think about because McKinney is fairly far north. That storm has to be moving fast then, because if it's in McKinney at 10:18, I mean McKinney is probably about 40 miles from here, 45 miles from like middle of Dallas. It's a good ways. To execute in order to exploit a target, each should be able to. Actually, we'll just leave it like this because we're gonna put the additional guardrails around this in the prompt whenever we build the prompt out. So what we'll do here is we will prompt the language model to give us exploit suggestions. That will become an exploit task. And then what we'll do is we'll then pass that over to, let's say, we'll pass that to a different node. That node will then tell us, it basically go expand the steps out. So we'll have a kind of conditional jump in here somewhere. Yeah, that storm's got to be moving pretty freaking fast if it's going to go from McKinney to Dallas that quickly. And plus, it's not even making a straight line, right? It's making, you know, like a 45 coming in. A little nuts. You did say the winds were getting kind of crazy, so that tracks. You can't even see it, but I'm going to still say it. Not sponsored by Jocko yet. Working on Jocko. Moving east, southeast. Yeah. Like, that's what I was saying. So, here, I got the map up. It's moving this direction, right? There we go. So it's moving not even, like, straight down. It's moving at what would take the longest distance for it to hit McKinney. Okay, well, actually, because if you look at it a little bit, back it up a bit. Get it. Because from McKinney to here, right? Like I said, it's making a bit of a triangle in the path it's going to hit. So it makes sense that it's hitting McKinney first. If it was a straight wall, it actually would hit Dallas first. If it's going straight east, it would hit Dallas technically first and then McKinney. Oh yeah, it is. Look at that sucker. For context, there's Oklahoma right there. There's Oklahoma. And then, let's see. I'm trying to see if I can see Austin, right? So Dallas is a little bit more than 2/3 of the way up to Oklahoma from here. So, but this storm system, look at the difference here in this line. This is about the same distance from Dallas to Austin. That's about how long this storm front is. That's nuts. That is crazy. Oh no, man! It's good to get it's good to keep situational awareness. Let's see. I think we do want to do one more output formatter. So we do want exploit steps. I'm going to make one more here. We're going to make another class. We're going to call this exploit suggestions. This will also expand our base model. And then what we're going to do is we're going to have, what do we call this? I guess we're going to call this tasks. And the task is going to be, again, I screwed this up. This is going to be a list of strings again. And then what we're going to do, dude, what is up with my hands today? We'll do another field, another description. And this one is going to be, let's say this, a list of, I would say a list of exploitation methods, method names that could potentially be used to exploit the target. Yeah, we'll say exploit the target for remote code execution. I'm going to add that in here too, for remote code execution. Which actually, believe it or not, that's not the only type of exploit we might want to get. There's a lot of times when I perform exploits and I don't get remote code execution, but it gives me another little piece of the puzzle to expand and then pivot into another system. That's what, guys. I will be right back. I've got to run to the bathroom because I had coffee before the Jocko and now they're just both hitting. So I'll be right back. All right, guys, I'm back. On top of going to the bathroom, I needed to go call my mother to check on her because I wanted to make sure she was aware of the storm situation and let Peaches go out to go to the bathroom because she's not going to get to go out for the rest of the night. So I was like, go get your potty break in while you can, Peaches. All right, cool. So we have our exploit suggestions, we have our exploit steps. So this now, rather than being an exploit task, we're going to change this to an exploit suggestion. And we'll leave that plural. Makes sense. All right. Probably what we'll do is rather than binding tools, we'll modify this to be with structured output. So let's do this. What we'll do is we'll make a new one. We'll say LLM with structured output. And what we want to do here is we'll call LLM, and we're just going to use that function, right? I'm not trying to be slick with the naming functions here. And what we're going to do is we're going to put in exploit suggestions. There we go. Hey, Will, thanks for coming online, man. Welcome in and hope you're having a very good Sunday. It is a good Sunday. Let's see. So what we're going to do is we're going to swap this sucker out. The response is going to need to change for this, actually. So let's move that up. And actually, I got to move this up as well. So this is basically the old way of doing it. I'm leaving it in here right now for posterity's sake. Why am I even worried about this? You know why? Because I have Git. I can always just go undo it. Let's just take this out and do this the fun way. All right, so we'll figure out this was structured output. I gotta remember how this does it with structured output, actually, because the way it returns it is a little bit funny. I think we did this in the initializer here. We did. So we have our response. Yep, so we get our response, we get our tasks out of that. Let me go look at this real fast. Let's see. How do we do this in initializer? I mean, so we get this information back. However, I think when we do the structured output, this is actually all that comes back when we get this. So one of the things that's handy, and there's a reason why we might do this as the previous method instead of doing it with structured output, is you notice that, for example, the initializer, it gets all this stuff in here. But we go over to Stinger, and let's look at the messages in here. Yeah. We look at the messages, we only have a human message. Initializer doesn't even show up in here. See that? So we could either... Yeah, I think I want to back this out just a little bit, because understanding how the language model is processing this stuff and thinking about it, or at least impersonating the idea of thinking, they don't really think, is a good thing to have. So I do want to go back this stuff out here. God, what am I doing? I'm in the wrong one. Hang on. Let me back this up. Back it 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 up. No structured output. I want the original language model with tools. And what we're doing is we're going to change this to exploit suggestions. I believe this will work if we do it this way. So we'll still have to go extract the tool call. That's fine. Let's see, which we do here. We need to go adjust our exploit suggestion prompt here. So let's go ahead and do that. Let's bring this over. And we'll worry about we're basically just going to run through each of the steps as we go through this. So our exploit suggestion prompt here says, your primary job is to analyze the task and target data to speculate on exploits that could be viable. Additional context may be provided for previously failed exploit attempts. So we've got that already extracted up here. That could be modified or avoided. Responses should be in a form, exploit and reason. Let's see. Responses should be in this form. Yeah, let's do that. We're going to add one more line in here. What we're going to say is, we're going to say, suggest 1 to 3 exploits that could be viable to get remote code execution on the target. Target, there we go. But that needs to be a backslash. There we go. Awesome. All right, cool. Ooh, that storm is moving fast. Let's see here. So in theory, hopefully what this will do is this will give us back a list of our exploits as it comes through. It should hopefully just provide us like a very simple list. So we give it the task, which eventually the task might be, right now the task looks like this. Come over here, right? Our task was get a remote code execution, or get remote code execution for a web shell. That's what we told it. Eventually it might just be, hey, go exploit this target now, or whatever. It might not actually have a suggestion on here, like of what type of exploit to use. And that's okay. Eventually, this task list, we won't provide it. Stinger will actually start analyzing, because right now Stinger is very basic, right? We look at Stinger, it is just handling task assignments. It's not doing any thinking at all. Eventually, Stinger will have another branch over here that says, hey, what kind of situation are we in? What data do we see? What kind of task should we suggest? Or maybe there will be like a new task suggested from Recon that then comes up and says, hey, what are we going to do here? So Stinger will actually work on generating those tasks and getting them going. Eventually, the initializer is actually just supposed to take user input, something like this, for example. Let's look at, this was an easy box, meow, right? Does this actually give any info? Hold on, let me try a different one. What was it? Omni. Let me pull Omni up. This was the one that What's His Bucket was working on last night. And so if we look at the machine info, eventually this would be the information we want to give it, and then like the target IP address, and say, here you go to it, have fun. And it will go through and begin filling out its own tasks. And so the first task might just be, hey, let's go do reconnaissance against it. That's what the initializer's job will eventually be. But then after initializer, Stinger's going to come in and start looking and saying, okay, what should be the next logical step that we do? And it will begin building out its own task list and then divvying those out to the various agents. Why my exploit is blue and the other ones are gold? It's telling me something different here. Very odd. Anyway. All right, so I think we've got the prompt kind of massaged in here. We don't want to do this. This is taking our current task and appending the response tool call to it. This is not exactly what we want to do over in there. Instead, what we want to do is actually we want to put this over into output. So we're going to leave the tool list alone. The tool list was actually not really being used for anything. The tool list was for our debugging and tracking purposes. Let's come over here. Let's take this out. How do I want to handle this? So from our response, what we should get is we should get an exploit suggestion. Exploit suggestion should be a list of tasks. So what we'll say is let's see, for task in response dot tool calls. And it should just be one tool call in here. So we should just be able to take the 0 element in that array. And if we take tasks here, what we'll then do is we will take those and we're going to put them over into the state table. So we'll say state tasks, and then we'll index that on the current task. And then what we'll do is we're going to say output. And then what we'll do is we will append that onto it. Call this an exploit task, and what this is going to be is, what did I call this over in tasking? Expand task basic info. So what I'm going to do is I'm going to just bootstrap this real quick. This will be expand exploit task info. Actually, I'm going to call this exploit. What I'm going to do is I'm going to call this expand exploit suggestion. There we go. And what we'll do is we're going to just pass in that task in here, that task string. And it's complaining because we haven't defined this function yet, but we're going to go define it right now. What we'll do is we'll come over to tasking. We're going to just make ourselves a new function in here. We're going to define this. X for our input is going to just be a string. And what this should return is an exploit task. Just like so. And then what we're going to do is we're going to return an exploit task. Actually, we'll probably need... We'll need a little bit more info than this. It's complaining because we have not imported exploit task. We'll import that real fast. So what we'll do is we'll just initialize each of these different fields here. So we'll say the status is going to be equal to new. And verdict is going to be equal to... Actually, I need to change this. Verdict is supposed to be a literal, which would be exploitable, non-exploitable. Can I change that to none? Or can I append none onto that? No, I can't. But what I can do is we can do pipe none. There we go. So now verdict should also be a none type, which is perfect because that's what we will do for this. So if we, that'll be our simple null value to see, like, hey, is it actually, do we have a verdict rendered for this? Let's see. Steps, what we'll do is that is going to just be a blank array for now. And then what we'll need is we're going to need the target IP. And actually, we'll need to adjust this a bit because we're going to need to pass in that target IP to this sucker. let's go ahead and extract this out real quick because I'm going to need it. So what we'll do is we'll do target IP like this, and then we'll define that up here. Just like so. Now why? Oh, what the heck is, why is it spazzing out on me? Because we're missing some syntax. There we go. So now we got our target IP, should be good here. And then what we'll do is we'll pass in that target IP here and the task. So let's go rework this a little bit. We do want I just realized we don't actually have an explanation of what the exploit task is. So let's go ahead and build that real quick. This should be just a string. Like that. So we do need to have that because this is going to be task is going to be the task variable. Good there. And then target IP, let's get that in here. So this is going to be target IP, and I believe this is going to be a string as well. Is that what we did? Yeah, string type. And then right here, nope, that's not it. Target IP, perfect. So what this is going to do is just return us a stub task that we can then append into the task output, and then boom, we'll have this good. Excellent. So now we've got our new thing here, but we need to import it. So we have our target IP and our task here. So we're good there. And then on our task output, that's when we need to append this. So what we're going to do is we're going to append the exploit task. Except this should be, let's go right here. So basically what we're doing is we're expanding the exploit suggestion into an exploit task right here. So I think this will work. So from the language model, we get an exploit suggestion back. The exploit suggestion is I think this is going to possibly fail up. No, it's not. I was thinking if this was coming back as structured output, because then it would make it a pydantic class. But since it's not, and it's just coming back as basic regular JSON, the response should work just like a typical dictionary in here. So we should be good. We could also, if we want to make sure we know what this is going to be, we could abuse IntelliSense just a little bit. We can come in here, we can say task is going to equal this, and then see what type task will be. Let's see, the type any. Okay. We don't need that. Let's take you out. I don't think I need that one either. All right, so we iterate over the tasks, we then expand them, and then we append them to output. And then what's going to happen is now we're going to check to see, does this thing have any steps to it? Because when it comes back, right, we're not going to have any steps associated to it. So the next step would be, we're going to have to go adjust our router to look at this and say, what's the next step that we want to take? If the next step is we have an exploit task that is in a new state here. So if we have an exploit task in a new state, then we're going to send it over to what do you call it? Like exploit prototyper, something that's going to then develop all the steps that we need to execute the exploit. That will be good.
Hello, Peaches.
She gets so offended when she's left outside for more than 5 minutes. Okay, so that's going to be our task string, our target IP. We bootstrap the rest of the variables in here. Excellent. Realize something. Let me see how much time we've got left. 16 minutes left. Yeah, add an hour. That'll get us through the rest of the string for now. All right, so task is going to be updated and returned. Current task is where the state current task gets set. Yeah. So notice how there is only one exception where we've got let's call it an extracted variable that we're appending to the state table. Typically, as we make these changes to our local copy of the state table, we then kind of emit those or return those back to LangGraph, and then LangGraph updates the master state table to get passed to the next node. One exception is messages. If I appended the new AI messages onto this sucker, then what's going to happen is we're going to just we're going to be missing stuff in there. Or sorry, what's going to happen is not that we're going to be missing stuff, we're going to be doubling up. So the messages log got artificially inflated with like duplicates of every message in there. This is the way, just because of the way messages gets handled. It's like an append. It's like a unique entry type value. It's kind of weird, but we're not going to worry about that. This should work just fine. I think what we want to do is we do want to log this, but I got to remember what the response is going to be. This is going to be our revoke retry. Response type is output. How do we get the message from that? Let me go look at recon. Oh, there we go. Agent message append response. That's what we did. So we're going to just do that. Oh, actually, I already got it in there. Yay. Perfect. So I think that should be good. I just want to try and run this one as is. Let's see what happens. Probably going to crash because I probably have an error in here, but you know what? We're going to try it. One thing it should do is it should go through and load the pickle. Okay, so we got an error right here during task execution for exploit agent. So what we can do now to kind of debug this is go hop back over to Hackbot and look at our last execution here. So we loaded our pickle. And the cool thing about this is you see eventually we go from input, which is the input state table, to the output. So it did load it. Looks like it did load it properly. See, we've got all the previous steps of information, so that's good. Exploit agent comes through and has a big old fat input table. All of our messages, collapse those down. So what do we have? We said it's going to be starting a new task, get remote code execution from web shell. We say sending get remote code. We're sending task 5 to validator for pre-flight check. Exploit validator comes back and says no initial access payload available, passing to exploit agent. Exploit agent then comes back and says what? Let's see. Well, it doesn't really matter necessarily what it says. Let's go take a look at the actual language model call. Let's see. Yep, so it's using the new prompt, so it did pick up our new information here. There's our data. We did get the task and target. Context is supposed to be just a null string, so that's fine. AI said, I'll analyze the target information to suggest viable exploits for gaining remote code execution through the web shell. Let me examine the available data and suggest the most promising approaches. Based on the information provided, we have a web server with upload functionality at panel. the panel directory, and it uploads directory where files are likely stored after being uploaded. This presents a clear potential path for exploitation. So the task, upload a PHP web shell to panel directory, bypass file upload restrictions to upload a reverse shell, use file inclusion vulnerability with upload file to execute code. So we're just missing a step here. The first suggestion should have been just perform like a perform dropping a web shell on the system or uploading and executing a web shell. That's kind of what we were shooting for here. This is more akin to what should have been happening in the next step. So we're skipping a step here. I like what it's doing. However, it's doing it too soon. We're rushing the plot. All right. But this is good though, because that means we're getting close. We can work with this in the next node. The problem is right now, we need it to, it knows what to do because we told it, hey, you're supposed to go get a web shell to get remote code execution. In the future, we're going to say, this is how you should exploit this system. And then go through and do it. So we actually will need suggestions like, hey, there's no clear-cut path. What are things we could test and speculate on to get execution? All right. That's what I got to go take care of something. I'll be right back. Alrighty, I'm back. I'm back. And I'm back with the peaches. No peaches. What? Everyone slip on me. Come here. Here. Here we go. Here. There we go. Kind of see her a little bit better. Here's peaches. Hello, sweetie. Was it good? Was it good? I know, you want your bed. Your bed is your favorite spot. I think she likes her bed under my desk the best because this is the warmest room in the house. With all the computers in it. I think it makes her the most happy. Let's see here. So we're skipping a step here. One other thing we could do is over in the prompt, we could just modify it a bit and we could tell it, give it examples of what we want it to do. But actually, there's another issue we need to address here, which is there was no key task returned. Okay, not a problem. I mean, here we go, right here. What error? Where's it erroring at on this? Let's see. So for task in response tool call 0 tasks. Error tasks delay. Now, why is this erroring? Because down here we see, well, no output data, but from the output from the language call, we see it right here. Just like that. Well, one thing we could do, we could try something real quick. I wish I had run this over in the studio. We actually may be able to access this in the studio. Look something real quick. Metadata. Do we have a thread ID in here? We don't. So I don't know if we can actually see this over in studio. Like, can we come over to exploit? Yeah. Because we didn't run it through the studio, we ran it directly. It didn't actually log it as a thread ID. We could have run it through here. That's what I should have done rather than running it directly. But you know what? That's nope. So on line 117, it says we've got an error here, and it cannot exploit or pull out the tasks. I'm going to run it one more time here. But this time I'm going to run it so that we could trace it. Right, so that all performed fairly quickly. So, okay, it actually gave us a little bit different information this time. But one thing I'm going to do is, let's bring up the terminal here. We can let this kind of chill out here. We can do something real simple, which is we can actually just tell it to... We just do a print debug statement on this. So what we'll do is, I think it's JSON. Not it? I don't remember where that function is. Yeah, what we do is just try printing the response. It's going to be kind of chunky, but it's not such a bad deal. Now whenever we run this, it's going to kind of suck because we have to dig back through the output from this. Really need to go get the output, the debugger connected over to the LangGraph dev server. Let's do new thread. Alright, cool. So errors out pretty quickly with just one language call, so that's nice. So we get an error for tasks, but here's the good thing. Let's take this over to code and modify it. And what I'm going to do is look this one up. It should be... Change this to Python. why this is throwing a fit. Go. So here's the actual tool call that's happening. Find this real quick. Got a whole bunch of stuff in here. That's our response metadata. So maybe instead of logging this, we need to log the tool call. Let's try that. Save that and then rerun it. Really should get the debugger hooked up to this. It just downgraded the watch from 80 miles an hour to 65 mile per hour winds. Dang. Well, I mean, there's a lot of stuff for that wind to get caught on too, so it's probably already gotten slowed down by a lot of the other stuff low to the ground. This is interesting. See this? So the output for this tool call is slightly different. Oh, I think what we want to do is we need to get the 0 element, and then we need to get the args and then tasks out of that. That's what we need to do. Yeah. Okay, there we go. That was the piece of information we needed. What we'll do is... Wait, where'd it go? Just had it. Yeah. Killing me, Smalls. Killing me, Smalls. Here we go. This is what we need right here. It's down to a bit. Let's modify this. So, and in fact, let's go ahead and extract this out of the response. So what we'll do is we'll say tasks. It's going to be our response. Dot tool underscore calls. There we go. And we do want that first element in there. And then we want is the args value. Say args. And then we'll say task. There we go. And then now what we'll do is we'll say for task in task. Perfect. Ta-da. You just have a thunderstorm warning coming out for Dallas. Love you long time. Aw. Alright, let's go try this now. Now that we've re-configured this. That is a technical term. Eventually, load pickle is going to go away. We're not going to use it. Hey, cool. So it did actually run. Let's look at the trace for it real fast. Alright, so the exploit agent makes a call here. Goes and gets exploit suggestions. Now, one thing I noticed here is that we told it responses should be in the form of exploit and to suggest the exploit. Which, so it's not following the proper output form. So we might go through and give it some suggestions so it knows how to kind of think about the structure of the output. That's fine. But let's see what it says currently before we start fiddling with it. So analyze targets, suggest viable exploits for remote code execution through the web shell. This doesn't have a web shell. Let's see. So based on the target data, I can see a web server running Apache 2429 on Ubuntu, 2 accessible directories, which are panel and uploads, a file upload functionality in the panel directory, upload form uses multi-part form data encoding. So task we could try is upload a PHP web shell with the file extension bypass. Nice, because that is what we're going to need. Upload a PHP web shell with the .far extension. I've not tried that. Upload a PHP web shell with image file polyglot. Ooh. It actually is giving us the ideas for this, though. I do like this, though. These are actually viable ideas that it's returning this time. I'm curious, though, what happened to the pickle and how did the pickle get updated? Because you notice how it didn't actually do a pre-flight check for it. I wonder what happened. I'm not going to stress over it now because it looks like we have a viable state table for doing testing right now, but this actually worked out pretty well. So then we hit the exploit router. Exploit router went to the exploit tool node. And I don't think the exploit tool node had anything like viable to call for it. Error, exploit suggestion's not a viable tool call. Yeah, I know. I know. It's because you're not actually supposed to go to the tool node from this. Yeah. Rick. I want to watch Rick and Morty. However, my wife cannot stand stupid humor. So I pretty much have to find time to watch it by myself, which is at an absolute primo. Let's see. This is fine that the exploit tool node failed. Not worried about that. And this is just that was an artifact of how we have the graph currently set up. Oh, you know what, let me go look at something real quick. What was our last message in our message queue here? Okay, so we did have this. We had all these little exploit suggestions set up. Happy wife, happy life. That is true. However, there's a corollary to that people forget about, and that is, you know, the wife should be working towards your happiness as well. Relationships are supposed to be two-sided endeavors. You're a team. It is you working together to better your family. If only one side is happy, that's not a really well-working team. And so I do try to keep my wife happy. And she is. She's very sweet. Especially considering everything we've been through over the last year. Jeez, I started thinking about it because I spent all day yesterday fixing the smoker, and I didn't think, it hasn't been out of commission that long. I was like, when was the last time? It literally broke last July. It's been out of commission for 11 months. The time has gone by so fast, and we've had so much going on. I worked on that thing for 6 hours yesterday, and still didn't finish everything, but I got it back to a state where I could go do like what's called a burn-in test on it and let it just basically burn pellets to get cleaned up, and then it would be good. And that alone took like 6 hours, which is hard for me to get like 6 hours to go work on a dedicated project outside of like in my employment. Okay. So where's the next place we want this to go? Let's think about this. The next place we want it to go is we're going to spin up a new node, which is going to be, we'll call it the exploit planner, actually. Let's go do that. Let's make us a new node in here. So we will have the router going on, but let's define a new node. We're going to call this exploit planner. Planet. And again, this is going to take in a stinger state. And so what this should do is, let's put a little doc string in here. Let's see. Take the current exploit task and plan the, what do we call those? Exploit steps? Yeah. Plan the exploit steps needed. So we'll have to have a little bit of logic in here because what we want to do is mark the first one as working and the second one's as new. Which I think we did that in tasking. We marked them all as new. It's fine. Dude, it wasn't just a crappy 2025 either. That's what I was thinking about in my head earlier today. I was like, you know, like 2025 feels like the year of death, but really it was 2024 and 25 because it all started last July after I passed the Red Team Ops course from 0 Point Security. That's when the smoke, actually, that's when the smoker went out of commission because that's when I had the huge fire in it. And then that was like the beginning of all the craziness. Smoker died. Thankfully, it can be resurrected. But then Panda, my dog, died. My sister died. A good friend of the family died. My wife's grandmother died. And then after that, I think it was I hurt my back. Worked really hard to recuperate it. Was doing okay. Then Elijah died, and then my dad died. It's just been bam, 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 one thing after another, man. So, yeah, here's hoping, dude. We will have to go through and do some checks on this. I think one thing we might do is hard code this to say if the last tool call was an exploit suggestion, then we're going to send it over to exploit planner. Yeah. Probably exploit router is probably going to get renamed and then duplicated because we're going to need other routing steps in the future. So we'll need other things to do conditional jumps in here. Actually, this works out pretty well. This error that we just got from here. Exploit suggestion is not a valid tool. So what we could do is we can look at the output from that tool call over here. Where was that? Dang it. It was somewhere way back here. I should have copied that out while I had the chance. If I could find it. Where was the last stack error and exception handler we had? There we go. Up here. There we go. This is what I need. Let me grab this real quick. Because what we'll do is we want to go through and extract out the name here. Because we can check it to say, hey, by the way, if the tool call has a name of exploit suggestions, then we route it to the exploit planner. That's what we can. Ah, crap. Copy this. There we go. Still praying for you, man. I mean that from the bottom of my feet because I don't have a heart. That's what you say, brother. I believe. I believe in your heart. Cool. So yes, what we can do is we can check the name. If the name equals exploit suggestions, then perfect. Let's go ahead and actually update the router for that real quick. What we're going to do is we're just going to do another check. It's going to say if last message dot tool calls 0, say name, equals exploit suggestions, then we're going to return exploit. And so we have not implemented this node yet, but that would be the name of the node that we're telling it this is where you route it to. I used to tell my kids, Gumby, that I didn't tell my kids this. I told my wife this. I told her I love you with my whole butt. She's like, what? I was like, yeah, because it's bigger than my heart. My ass is bigger than my heart. I think this is coming along nicely. We got about 30 minutes left on the stream. Let's see if we can get the exploit planner portion put in. Let's see if we can expand that just a wee bit. In fact, what's probably going to happen is, as the graph currently sits, right here, we have the tool node attached to exploit agent, and then nothing. This tool node is probably going to move over here into this new branch of execution that we're putting in, where it'll be part of this kind of Reflexion agent workflow that we're going to implement into this. Man, this is coming through so cool. Let's see. So exploit planner. So what are we going to need to do for this? What we're going to need to do. Let's think about some steps for this. Let's see. Exploit steps needed. So we're going to take in the current exploit task and plan the exploit steps needed. So what we're going to do is we're going to let's kind of metacode this a bit. So we're going to, in fact, I won't do this up here. We're going to just do this down in comments real quick. So we're going to extract the current task. Then what we'll do next is we're going to extract the current exploit task from task output. Yeah, we're going to do dot notation, even though this is just metacode. Let's see. Storms may still hit. Let me update the radar. Curious about that. So after we extract the output, what we're going to do is we're going to find the current working exploit task. Actually, it looks like it's really getting over to like Dallas right now. I'm looking at the radar. That's at 10:30. Yeah, it's about the time I had anticipated it hitting. Oh no, it's gonna hit. That's bigger than shit. Yeah. Although it's kind of cool that it anticipates the heat bubble around Dallas. So if you're not familiar with this phenomenon, what happens is in large metropolitan areas where there is a ton of concrete, especially sprawling concrete like Dallas, because it's a very spread out city, what happens is all that concrete is storing heat. During the day, it's just giant solar collectors, right? And then at night, it's releasing it, and it makes this kind of like heat shield around the metroplex. And it's very frequent you see it that when storms hit, they just split and diverge and kind of like almost bubble around it. So the part that does get through to the central part of the city just really dissipates and is weakened, and then it just kind of forms around it. Dallas Metro is huge. Oh yeah, it is. And that's just the Dallas part. I mean, you're talking about you've got here. Let me pull up the map real quick. So this is the Dallas Fort Worth Metroplex. Here's the balls. Here's the tip. Can't see it there. So what happens here is once it starts hitting this area, especially downtown Dallas and downtown Fort Worth, where it's very dense concrete, it kind of has this like heat bubble effect. In fact, I think you can see it here a little bit. So this is the projected, right? Look how it just kind of weakens around here. They even put that into the forecasts a bit, where it looks like it's going to weaken as it goes around the Metroplex. There you go. Now you can see the balls and the tip. This is how I explained it to a lot of the California transplants when they moved here. Dallas is the balls. Fort Worth is the tip. So yeah, this whole area is pretty much, except for some areas here in the center, like concrete jungle. It's very, very concrete heavy. Let's see. So let's think about this. We find the current working exploit task. We're going to call LLM to supply, what are those, exploit steps? Yeah. Exploit steps to complete the task. That's actually it. That's all we want for the exploit planner. So let's just use this metacode approach to start planning this out. So we're going to extract the current task. So what we'll do is we'll just say current task is going to equal to state table. And that one's actually real simple. It's just current task. So we take the current task and then extract the current exploit task from the task output. So this will be real simple. So we'll say our what do I want to say? Exploit task, that's going to be from our state table. We'll get from task indexed on the current task. And then from the output. Actually, I need to say current working. So we're actually going to need to iterate over this. Yeah, so actually we're going to have to iterate over this field because there could be other failed exploit attempts in here. So what we'll do is we'll say for or exploit task in this output. And what we'll do is we'll check real quick. We'll say if, let's see, what is our exploit task? If exploit task status equals working, then we return it. Actually, no, we're not going to return a correction. Then what we'll do is we'll set that to I got to remember how to do this. Actually, what I want to do is I want to track an index of it, maybe. Because typically when we're working through these lists, we're tracking the index of where we're working in the list. So do I want to track that here, or do I just want to store this locally? I gotta remember how to do that. Oh, Peaches. Oh, do you hear the thunder? It's okay. It's okay. I guess Peaches has not really been sensitive to thunder, until recently. I guess when the storms have just gotten really bad. Yeah, you just sit there. You'll be fine. You're safe under my desk. Let's see. Python. Iterate over list and get index. Oh, is that what we went the enumerate? Yeah. That's what we want. Yeah. Index an element and then enumerate the list. That's how we do that. Actually, I'll just do this. Yeah, I like that. We'll just call that exploit task. Why not? So it's going to iterate over this. We need to enumerate this, though. There we go. So what we'll say if the exploit task, if the status is working, let me do this. Let's do exploit task. And what we'll do is we'll just define this as like an empty string, and then we'll do exploit task index. And I'm going to do the same thing here. One of the benefits of a not a strongly typed language is I can do this. I mean, if this was a strongly typed, we just say what type this is going to be. We'd say, by the way, it's going to be a type exploit task. And then we just don't initialize it. Let's see. So then we'll say the exploit task is going to be here. And then we'll do one more thing. We'll do exploit task index is just going to be equal to index. Oh, wait, this is, I forgot, I'm overloading variables here. I don't want to do that. Let's clean this up. Can you prepare a group YouTube channel Discord page? I'd like to join you. Yeah, so it should be, I think if you do exclamation point Discord, I think it should come up. I thought I had it in there. Try that. It might not do it whenever I'm doing it. But try it on. See if you type in exclamation point Discord if it will bring it up. I thought it would. For some reason it does. There you go. I'll just drop it down in here. There you go, bud. I guess I need to go fix that in Nightbot. Nightbot's kind of ridiculous because I have to change which login I'm using. You have to authenticate to Twitch, and then you got to authenticate to YouTube. I wish you could kind of just combine the two and have a single set of commands to work with in there. Thanks, Gumby. Yeah, it looks like it is. For some reason, I didn't set that up in YouTube Nightbot, which is weird. That's all right. I was actually trying to migrate most of those commands off of Nightbot, but fine. I just realized I'm overloading this stuff. So rather than doing index, I'm going to call this element. Yeah, there we go. Use stream elements. I've thought about it, but honestly, with some of the multi-streaming I'm going to do, I am planning on adding in streaming to a couple other platforms as well. In addition, even though I like Twitch for what it does, I was going to add a couple more in there. So really, it's a little bit more difficult than that. for some of the commands. So like, I'm trying to figure out a solution where like I have a single point of management for all of them. Night thought is just a stopgap right now. Let's see. So extract the current working exploit for or from. There we go. Find the current. Wait, add that in there twice. I don't need that. All right, so once we have this in here, so we extract the current working exploit from task output. Call the language model to supply exploit steps and complete the task. So what we can probably do is, over here in prompts, we can probably make a lot of use of what's happening with get exploit suggestion prompt. So what I'm going to do is actually just copy this sucker. Instead of exploit suggestion prompt, we're going to just call this exploit steps. And then we can just modify this one right here. So we want it to be fairly similar in here for our prompt. This is the beating heart of everything you're going to do talking to the language model is your prompt. So the way I'm typically setting these up is our system prompt contains all of the actual instructions, and the user prompt contains the data to complete the instructions. That's the way I've been structuring. Let's see, your primary job is to analyze the task and target and speculate on exploits that could be viable. So what we're going to do is we're going to change this. Your primary job is to analyze target data to plan steps. What do we want to say here? Basically, to plan steps. Plan the steps necessary to complete the exploit task. Yeah, we'll say that. We'll say to the steps necessary to complete the exploit task. Additional context may be provided for previously failed exploit attempts. Let's see. It could be modified or avoided. We don't care about suggesting 1 to 3. So what we want to do is, we don't necessarily care about what the response form is. Responses should, let's say, we'll say provide a list of, what do we say? A list of steps and the reason for each step. There we go. And I think the same user template will work for us, because we do want the task. That would be the exploit task. So actually, I'm going to modify this a wee bit. What our target is, this is actually going to be the target object. Context, I'm not quite sure how we're going to use the context for this. In fact, I think I'm actually going to take out... No, I'm going to leave the context in for now. It might be blank. We might modify it later. If we're sending 2 extra square brackets, 2 tokens doesn't mean anything when you're charged by the millions of tokens. So I'm not going to worry about that for now. What I was thinking offhand was, though, the context could be, let's say we're on exploit attempt number 2, right? We could go through and we could see what did we do for exploit attempt 1 that failed, to provide additional ideas to avoid what happened for exploit attempt 2. Maybe exploit attempt 1 and 2 are very similar. But I think that will work right there. Fornax, I just want you to know two things. One, welcome. Thanks for coming online. And two, how much I love that dial-up sound, because that is literally the sound of my youth. And Gumby, yeah, I know. I know it. You know it. Everybody knows it. I'm a giant. Let's see. Yeah, I think we'll be good here. Hey, welcome in, man. Let's see. So what do we want to structure for the context of this node? I think for now the context is just going to be blank.
I can't hear you. Sound off like you got a pair.
Gumby, you give me trust issues, bro. I know you can hear me. I know you hear me. Let's see. I think we already have, let's see. We do have the exploit task. That is good. Which is one of the variables we're going to need for the prompt. Other one is going to be the target, which we can get the target IP from the task. Let's go ahead and do that real quick. Actually, let's get the target IP from here, and what we'll say is the target IP is going to be current task and target IP. That should be it. Oh, no, that is not correct, actually. Because current task isn't the task itself. This is the this is just the index to the current task. So actually, I need to modify this. What we're going to say is the target IP. We're going to get that from the state table. Task. Index it on the current task. And then from the current task, we're going to then we can get the target IP. There we go. Just have a way to waste channel points. I added all new sounds, and the one you go with is the gunny. I added a whole bunch of new ones. Especially because Band kept badgering me about adding sounds from the original 1995 Hackers movie. Gosh, that was so long ago, man. That was a while ago. Let's see. So we got the target IP. That will be this guy right here. Actually, that won't be that right there. I take that back. That's not going to be the target IP is what we want. But it's okay. Actually, we can use this because the target is actually supposed to be the object for it. So not a big deal because then we just extract that back out. So we'll say host and then say target IP. There we go. So there's the actual target variable that we want. We do have our exploit task being set here. Now there's a potential issue here as we're working this. It should not happen, but in the off chance it does, let's say none of the tasks are set to working. We need to go do an exception handler, not an exception handler, but basically an execution branch for in that situation. Probably much to my chagrin, I'm going to overlook that for now, and we're just going to let it be. Only had 1K channel points. Let's see. All right, let's set up the language model call, and I'm basically going to copy the format for it from up here. Exploit planner. We'll just start with this. So let's change some names around here. This will be our exploit planner prompt. Except I can't spell correctly. There we go. This right here will be Oh no, this isn't. This is exploit steps. Forgot about that. This is not exploit planner. This is the exploit steps prompt. Maybe I should call that planner instead of exploit steps. Yeah, actually, I like that better. It makes it sound, because also then this function is called the exploit planner. So it ties it together a little bit better in here. Exploit planner prompt. And I gotta change this value here. Enter. And it's complaining because I haven't imported this from prompts. Same thing. Oh, oh. Okay. There we go. So our task here Hey Eva, what's going on? Welcome in. And happy Sunday. Dang, is it almost 11 already? Man. Oh, this should not be template. Oh wait, yeah, it should. Wait. Why is it saying there's no invoke in function? Oh, because it should be like that. Wait, no, that should be correct. Yeah. Because we execute the function to get the prompt back. Oh, that's why, because it should be this. Duh. There we go. I was calling this instead of calling this. So basically what should happen is this function feeds this variable we invoke, feed this variable. Working and lurking. That's what I expect from most folks. If y'all would have come in and chat, I'm more than happy. That makes me feel good. Just to be completely honest. But if you're just coming in to chill out while you're working on your own stuff, I fully expect that too. Let's see. Actually, this is not too bad because what we can do is we can actually reference this off the exploit task block notation. Hence, because our exploit task here, it's used. I gotta trick something about this because this kind of bugs me. Python declare variable without value. Can you do that? So in Python, you cannot declare a variable without assigning it a value. So unlike some other programming languages, Python does not have a separate declaration step. That's what I thought. I didn't think we could declare that without using it. Which hence the reason why these are being initialized as blank strings is because I need them actually to exist outside of this scope here. Let's see. So our exploit task is going to be from our current task output. Oh, I just noticed there's an error in this. We need to index this on the index value. Because if we don't, we're going to get the entire array back. We don't, we just want that array. We could also just do element in here. So, come to think of it, element. Let's see. Is it? I'm kind of curious to go check out the window, but I don't want to step away because I want to finish this up. I at least want to get this function finished and get it piped into the graph to run one quick test on it and see what kind of data it returns real fast. Let's see. Context for now, I can literally just make it a blank string. We don't actually... What am I doing here? fat finger and everything. Let's see. Did we actually extract the target? We did. So we extracted the target up here. I'm going to say change this. Extract helper variables. So we're going to extract some helper variables up here. We want the task. Let me double check that real fast. So for exploit task, we do have a task key, so that's perfect. We have our target, we have our context. I think that's good right there. So once we get those back, what we're going to have to do is our language model. We need to prepare our language model with the exploit step output formatter. That's what we have to do. So let's do this. So we'll do, what was it? LLM with tools? Is that what the function is? Yeah, LLM with tool. Yeah, LLM bind tool. All right, we'll just copy this whole section right here, even though it's not correct. And we'll just make a modification to it. So rather than exploit suggestions, this could be exploit steps. And our prompt is going to be our exploit planner prompt. Exploit step needs to be imported. So we import that. And then the last thing we'll need to do is we need to go update the state table for the task. Actually, this should be our steps right here. So we need to extract the steps out of it. And it should be steps, just like that. And then last thing we'll do is let's make it, let's see, update state table. Just call it that. So we do our steps here, and then what we're going to do is we're going to hit we're going to say state task indexed on current task. Yep. We'll take the current task, and then in the output we're going to index that on, what's it? Exploit task index. Yep. That's what we're going to do. And then inside the exploit task, the steps. Oh no, this is not the actually this is going to be, yes, the exploit task inside steps. That's what we're going to append it to. There we go. Excellent. And then we'll do one more thing. Then all we have to do is actually just return that value right there. So what we'll do is we will return what was this? This was tasks in here, yeah. So what we'll do is we just return the keys that we've modified in our local state table. And what we'll do is we just return state tasks. Just like that. That would be good. We need one thing we'll want to do is we'll want to add some AI logging messages in here, but that should be just fine. Let's see if we get any errors. Server, none. Okay, I want to run this real quick before the night ends, and then if it works halfway decently. Oh, you know what? Except I'm a freaking moron, because guess what we didn't do? We didn't actually pipe in this function into the graph. So we updated the router. Hey Ty, what's up, man? We updated the router, but we didn't actually pipe it in to anything. So, for example, if we come up here to the router, we said, hey, by the way, go to exploit planner. but we haven't added the exploit planner node or the path for it. So what we need to do is come down here to the graph. Potential path, we need to add, let's see, exploit planner as a potential node. And then what we need to do is we need to add another node here. So we'll come to the exploit workflow. We will add a node and we'll call this the exploit planner. And the function it's going to be associated with is going to be exploit planner. There we go. So let's save this, and then we should see this reflected over in the studio. Whoop. Put this over here. Hey, exploit planner. Nice. All right, run. Run quickly. It actually should run pretty quick, so there's only going to be 2 language model calls that happen in here. Oh, rip. Rip-a-roni. Let's see. Type error. String indices must be integers, not strings. Where did I cause this to happen? Line 167. Let's go see if we could fix this real fast. We iterate over the current task output, which is where the exploit tasks are going to be stored, because that is the output for the task is, hey, here's the exploits that we're doing. You pooping? No, I'm not pooping. I'm on stream. Does this look like, hold on. Does this look like a porcelain throne? Killing me, Smalls. I don't know your life. I am not about that neat life, bro, where I've just got the hole cut into the bottom of the chair. No. No. You can presume that. You can just go ahead and presume that, Cypher, that neat life is not happening. Let's see. So why is it complaining about this line right here? So exploit task equals the element, which should be... So we're going to iterate over the list of the exploit tasks. Hold on, let's go back and check something real quick. What kind of output did we get back from this? We got 3 tasks back in the list. So if we look at exploit planner, let's go look at the task group. Let's look at task 5. So we look at 5, output. Nice. So all of the individual exploit tasks are structured over here in the output. Bam, bam, bam. Oh. One of these, none of these are set to working. See that? Since none of these are set to working, it didn't know how to execute. See that? Okay, I'm gonna. This was. I knew I was gonna run into this, but that's fine because here's what we'll do. If none of these other ones come back, think about this. So it iterates over each one. If it finds one that's working, we extract the exploit task and the task index. But what we need is we need a catch in here that says, hey, if this value isn't set. So simplest solution is, let's actually just change this from a standard string to a none in here. Make it real simple. What we'll do is we'll say if exploit task equals none, then what we're going to do is we're going to go grab the 0 element. Actually, what am I doing here? I'm making this way more complicated than it needs to be. Because one thing we could do, we back this up a bit. One thing we could do is we could just check to see if it's new. We'll do is we'll say if, yeah, we'll just copy this. So if the element status equals new, then we're good. We know which one to start working on. In fact, we can even do this. We can say if it's new or if it's working, then that's fine. Just like this. If it's new or if it's a working task, then bam, yeah, we want to take these two values right here. Yep, and then now we can do this. So now we'll say if exploit task equals none, then we bail. That's what we do. Let's see. I'm gonna call this the bailout back to exploit suggestion. There we go. Love the t-shirt. Dude, one thing I like about this t-shirt, though, is that... Where is it? Right here. This is supposed to be green, but it's like the perfect chroma key green for the backdrop. So it's just kind of transparent. But I do like this shirt. Unfortunately, so many of my old nerdy shirts are old. They're just getting nasty holes in them and stuff. And I've had to retire many shirts. And my son's like, why are you throwing that shirt away? I was like, because this shirt is from the previous century. That's why, son. That's why I have to throw this shirt away. All right, let's try this again. Now that we've fixed the checking on this. Let's close this up, close this up. Let's run this in a new thread. Submit. Let it do its thing. All right, we got a new error over in exploit planner, unfortunately. Let's see what happened here. Key error. Input to trap prompt is missing variables exploit task. Ah, I'm an idiot. What it's saying here is that over here in prompts, we have exploit task and we didn't match the key here. So it was working. It was working. It was doing stuff. I do need to add some AI logging messages like, okay, we're working on exploit task index blank here. Do you know if you were born before 1998, you're older than Google? Oh, dude, I'm so much older than Google. Speaking of, if you were born before May 24th, 1985, you were older than AOL. Fudge, that makes me feel old. I'm older than AOL. Damn. I don't know. Have you ever really lived if you hadn't played AOL CD Frisbee? Have you even really lived? Jeez. Man, you had to make me look that up. Graduated before AOL. Hey, kid, what's up, brother? I still can't get over the Magellan search engine or Ask Jeeves. Man, I hadn't thought about Ask Jeeves in a long time. Hang on, let me make sure I saved this change. All right, it must have, because it didn't admit any new changes to the dev server. All right, go forth, exploit planner. A new error. Yay. All right, I don't know if we're going to get to see this actually suggest the exploit steps. What do you mean error and steps? You dirty, dirty girl. What is all this crap? What is this? Okay, hold on. Let's look at something real quick. What's the task we said? The task was upload a PHP file with obfuscated content to bypass potential content filters. Okay. The AI says, I'll analyze the task and target to plan the steps needed to upload a PHP file with obfuscated content to bypass the content filters. Okay. Based on the information provided, we have a web server running Apache. There's an upload on panel. There's a directory on uploads. We need to create and upload obfuscated PHP files and content filters. Okay, this prompt is going to have to be completely reworked because it's just giving us bogus data here. And did I implement? Oh, is that what happened? Yeah, I know what happened. So let's back it up here. Back it up. So we are binding an exploit step to this, right? And we're telling it, hey, this is how you should structure the output. So we're not actually making a tool call. What we're doing is we're doing a fake tool call to say, give us your reasoning so we can understand it and point it in the right direction. But then also, this is the structure of I want a structured output called a tool call to come back to us. So we define it here. The problem is, if we come up to the very top, I know exactly what the issue is. We're importing exploit step from the states table. That's the problem. This is no bueno. This actually needs to come back from output formatters. So it's sending the wrong data structure, and that's why it's returning that weird, funky data structure. Now, hold on, something is amiss up here. There we go. Got a dangling comma. Yahoo search engine was the Google before Google. Oh yeah, dude. It was. It amazes me like how Yahoo went from being like this this just like monolith, right, to being an absolute joke online. I mean, if you think about it, the same thing happens to so many businesses. Way back in the day when typewriters were the big, shebang, they didn't adopt word processors like computers, and that's when they just ate it and crapped out and died. Same thing happened to Blockbuster. Blockbuster did not adopt the idea of Netflix, which they had the opportunity to buy Netflix and passed on it. And then now Netflix has completely crushed them. Eventually there will be something to crush the current monoliths in there. It ran and we got no errors. That might be the best thing ever. All right, so what did we get back? Create a PHP web shell with obfuscated content. Okay. Encode the PHP code using base64 to obfuscate the malicious content. Use PHP's eval function. So it's working well here. The problem is we don't need it to do all these additional steps. We already have the ability for it to query and get a web shell, like an approved artifact of a web shell for this. It's getting close though, guys. It's getting so close. Peaches, what's wrong, baby? Hey, it's okay. Poor baby, she is spazzing out over the thunder. It is okay, honey. You don't have to shiver. It's alright. Hey, you're safe. You're a safe puppy. Yeah. Hey, it's okay. Come here. I'll move your bed right here. Look at you. It's alright. Snuggle my feet. Poor doggy, she is shivering from the thunder outside. Alright, guys. Unfortunately, that is where I've got to call it tonight. But this is awesome. It is finally doing stuff. This is great. We'll have to massage this just a wee bit, right? Is it all over? Yeah, I bet it is. We'll take one last cursory look at the weather map. Oh yeah. Oh yeah. The poo has hit the fan. Look at that. Dang. For context, this is my hood right here. This square right there. Let's see, does it show where Dallas County is? Yeah. So Dallas County is where I live, and it is just boom. I may be Thor, guys, because as soon as I said boom, this giant rolling thunder just hit. Just saying. Let me see how fast is this sucker moving. Let's see. So these are 5-minute slices. Look at this. So for like, let's see, like data comparison. I think from here to here, from this square to this square, I want to say this is probably about 40 miles from corner to corner. Look how fast it goes. So right about here, what is this? This is 10:10. And then it hits the second corner at 10:45. So in 30 minutes, right? So it's traveling about 55 miles an hour. That is freaking insane. Time for a Storm Chaser IRL stream. You know what? I learned tonight that Gumby actually is a Storm Chaser. So if I ever get to go do that, you better believe I'll try my best to do an IRL stream. I think that'd be pretty sick. All right. Unfortunately, that's where I've got to wrap it up. Let's see if anybody's on InfoSec streams, which they're not. So if you've got raid suggestions, shout them out. Let's go see who we can find out to go raid for tonight. Stay in your bed. It's okay, babe. I know the thunder's scary. You're okay. It's okay, baby. We can make it happen. That would be sick. But I just have to convince Sock. Let's see. Hey, Peaches. Man, poor baby. She is freaking out. Let's see. Oh yeah, the thunder is really blasting. What's crazy is she never used to be this scared of thunder. Maybe just the storms weren't that bad. Poor baby, it's okay. Bring Peaches with us? Oh god, no. She's such a nervous wreck whenever she's in a car, let alone a car with like hail and thunder and rain and stuff. You're talking about a recipe for disaster. Let's see. Who could we go raid out to? Hypnotic's on. He's working on his game right now. Oh, bring Sock with us. Oh, I thought you were talking about Peaches. Oh no. No. Only one of us is allowed to be in a life-threatening situation at a time. We're both not allowed to go skydiving at the same time. Or deep sea diving or cave diving or anything like that. No. Anytime where there is a better than normal chance of dying, we cannot do those together. They have to be one at a time. All right, I think we'll probably go right over to Hypnotic because he's doing fun stuff with his game dev. He's having a good time. All right, guys. Unfortunately, that is where I've got to end it because Sock is going to come in here and yell at me in just a minute. But this is awesome. The exploitation agent is moving along and it is getting some good traction. We're getting close. We need it to chill out on the obfuscation. We don't care about that part, but maybe that's something else we'll work on in the future here. So, very awesome. Folks, I will see y'all Tuesday night. We'll do Hacker News. We'll have a good time with that. Hopefully, we'll check it out. And that's all I got. Keep crushing it this week. Tomorrow, it may already be your Monday, in which case, continue crushing. Go forth. For everybody else whose Monday starts, after you sleep, go do it. Hit it. Destroy this week. That's what I got to do. I got 1 week left on my current pen test, and I need to go absolutely wreck house in there. But I think that's all I got for you guys. I'm going to go check out the storm because that's a Texas pastime, is just go look at the storm as it's about to kill you. I don't know why. It's just a very southern thing. I'm going to go do it. So that's all I got for you. I want y'all to remember one very important thing, and that is, I love you. Peace.